what we want to do is find the derivative of this g of x. And at first it could look intimidating. We have a sine of x here. We have a cosine of x. We have this crazy expression here. We have a pi over a cube root of x. We're squaring the whole thing. And at first it might seem intimidating. But as we'll see in this video, we can actually do this with the tools already in our toolkit, using our existing derivative properties, using what we know about the power rule, which tells us that the derivative with respect to x of x to the n is equal to n times x to the n minus 1. We've seen that multiple times. We also need to use the fact that the derivative of cosine of x is equal to negative sine of x. And the other way around, the derivative with respect to x of sine of x is equal to positive cosine of x. So using just that, we can actually evaluate this, or evaluate g prime of x. So pause the video and see if you can do it. So probably the most intimidating part of this, because we know the derivative of sine of x and cosine of x is this expression here, and we can just rewrite this or simplify it a little bit so it takes a form that you might be a little bit more familiar with. So actually, let me just do this on the side here. So pi over the cube root of x squared, well, that's the same thing. This is equal to pi squared over the cube root of x squared. And this is just exponent properties that we're dealing with. And so this is the same thing. We're going to take x to the 1/3 power and then raise that to the 2nd power. So this is equal to pi squared over, let me write it this way. I'm not going to skip any steps because this is a good review of exponent properties. X to the 1/3 squared, which is the same thing as pi squared over x to the 2/3 power, which is the same thing as pi squared times x to the negative 2/3 power. So when you write it like this, it starts to get into a form. You're like, oh, I can see how the power rule could apply there. So this thing is just pi squared times x to the negative 2/3 power. So actually, let me delete this. So this thing can be rewritten. This thing can be rewritten as pi squared times x to the negative 2/3 power. So now let's take the derivative of each of these pieces of this expression. So we're going to take, we want to evaluate what g prime of x is. So g prime of x is going to be equal to, you could view it as the derivative with respect to x of 7 sine of x. So we could take, let's do the derivative operator on both sides here just to make it clear what we're doing. So we're going to apply it there, we're going to apply it there, and we're going to apply it there. So this derivative, this is the same thing as, this is going to be 7 times the derivative of sine of x. So this is just going to be 7 times cosine of x. This one over here, this is going to be 3, or we're subtracting, so it's going to be this minus, we can bring the constant out that we're multiplying the expression by, and the derivative of cosine of x, so it's minus 3 times the derivative of cosine of x is negative sine of x. Negative sine of x. And then finally, here in the yellow, we just apply the power rule. So we have the negative 2/3. Actually, let's not forget this minus sign. I'm going to write it out here. And so you have the negative 2/3. You multiply the exponent times the coefficient. It might look confusing, pi squared, but that's just a number. So it's going to be negative, and then you have negative 2/3 times pi squared times x to the negative 2/3 minus 1 power. Negative 2/3 minus 1 power. So what is this going to be? So we get g prime of x is equal to 7 cosine of x. And let's see, we have a negative 3 times the negative sine of x. So that's a positive 3 sine of x. And then we're subtracting, but then this is going to be a negative, so that's going to be a positive. So we could say plus 2 pi squared over 3, 2 pi squared over 3, that's that part there, times x to the, so negative 2/3 minus 1, we could say negative 1 2/3, or we could say negative 5/3 power. Negative 5/3 power. And there you have it. We were able to tackle this thing that looked a little bit hairy, but all we had to use was the power rule and what we knew to be the derivatives of sine and cosine.